So I'm erasing where it was E1 and E2 on the diagonal, right? Because we need interaction Hamiltonian.
Wait, isn't that the exact solution?
But yeah, for exact solution in the rotating frame. What's wrong? And then instead of cosine, I will be typing whatever we derived together. Exponential I.
Isn't it positive I?
You can dictate me because I cannot look backwards at the same time.
It's IT.
Okay.
Times energy difference.
Second minus.
Yeah, second minus first.
Thank you.
And then that's over h bar.
Okay.
Plus big omega.
Plus or minus?
Plus.
Oh, there was a little minus here.
Oh, okay.
Okay. Plus big omega. And now I need just to double check that it is all brackets are closed in the right way. Does it look similar to what it should be?
No, yes, yeah.
Good. Thank you. And now
no, but that would omega, big omega is the energy offset.
And
probing, that's the wavelength. Yeah, but that's the exact.
And for the
Big W is for
opposite off diagonal element, I'm changing signs, plus here and minus there.
energy. So if you have two states, your energy is here, or here, and here. Yeah, but you have to do it right.
Okay. Save and run. I don't remember what it was before. Ah, I know how I do it. I run the previous version and I run then I do another figure and run the new version. And we are comparing the red lines. So after the we have forgotten v divided by 2, right? So it's not yet a fair comparison. So it should be 0.5 up front. Save. Okay, well, to my eye, they look very similar. Bless you, bless you, bless you. Okay, so I just don't care right now for perturbative solution. So change only the part of the code that deals with numerical exact solution with the evolution operator. So the image on the left is the one in Schrödinger picture with exact Hamiltonian. So it is this red curve. Do you see it? And it has little wigglings, little fringes, oscillations, because of the oscillating nature of the perturbation. The red line in here, in the second frame, is a result obtained in the rotating frame by dropping the co-rotating terms. So you see that it raises with the same pace, but it doesn't have these little oscillations. So the price of dropping this co-rotating term is just have it smooth rather than shaking. I think if you get same pair of pictures, it would be enough for today. Let me walk around and see where we are now.
My divergence for some reason. I think you just might put a sidebar in somewhere. In the what? Where?
What? Apple ID and phone number. Interesting. It's going to do something very good.
Well, you just changed just those two things, right?
That's all I did. Oh, now I did not. Please, I changed.
Can you?
H bar.
Do you have the old copy?
Put in parentheses H bar.
It would be reasonable to if you make this exercise, design new name for the code so that you do not spoil old good work. Like call it time dependent whatever in rotating frame, so that you can run both old and new code and compare.
There's more maybe?
What? You got something? Do you divide by 2? V divided by 2. 5 divided by 2.
Or maybe point, much better point, right?
Yeah. Because of this point, divide by 2 factor when you represent cosine with two exponentials.
But still is higher than this one is polarized on down, right?
Yeah, this is all on top.
Or the time is good.
But you see some similarities.
Yeah.
So if it gives some benefit in
But in that case, partial result was higher than
can you remind what are the dashes and
dash one is the resonance one, and this one is the partial solution. Partial version, yeah. And this one is the real one.
Can you show maybe in the different panel the solution with the same parameters but without this approximation? Just run the code with old version of the code, which you may have in the same directory.
I had it, but now we are trying to do both at the same time.
That's a good point.
So hopefully I didn't break it.
You're reconstructing the previous one? No. Is it, which one is it? Is it that one? Then you should remove E1 and E2. Oh, make zeros. So if this was the main point, to remove E1 and E2 memories of the production container. And here you
This has to be divided by 2.
Yes. Did it hit anywhere near?
It didn't look like the curve showed up.
Oh, maybe it placed it into forward.
Yeah.
That's
Well, there's going to be an assignment at some point, right?
Yeah.
Okay.
So they look similar?
Yeah.
More similar than in the example by Jebet? By some reason, in his case, upon this change, the red line was on the top of the street. Not much, but a little.
It went up.
I like what you're showing. I do it more.
So mine's better than Javed's?
Well, he has a couple of minutes to pick up.
Why do you ask me no points?
Oops.
I see. I see what you would get something really impressive, surprising. Yes. Multiply and make sure that the brackets are on the right. Let's go open, 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 close, close, close. Number of brackets seems right, but so without this, it looks like the omega was not multiplied by t, was not multiplied by imaginary unit, and it was like real part in the power of exponential, which will get immediate raise or immediate drop.
Try better.
And then we also need to divide by 2. If we divide multiply by 0.5, better?
Mm-hmm. I think my time scale is longer than yours too, so it might diverge a little bit.
Mm-hmm.
Excellent.
And that one too.
So you got some figures?
No. It's
At least for numerical exact solution. Did you get? Can you run it and show me?
I'm getting an error which says that the dimensions are not mismatched here, but I didn't touch these lines, so I don't know how this one's not correct.
But before you started,
Yeah, I could before I added this second one. So if I copy this, and
so you believe that this could be useful. Good.
now I'm just perplexed on why the other one's not working. It says, as you say, 10% of the developmentation of the code is writing it, 90% is figuring out why it's not working.
Exactly. Therefore, I stopped right immediately after we got something positive.
Yeah, sure.
Do you have the same set of parameters?
This one is original, just change the vectorial. So it's giving this
Do
one.
you multiply omega by time? Where's your time? What is
the hell? That's
Oh,
I don't know what is it. Oh, yes. I mean,
this
you
one
have the the same set of parameters because maybe they. What is your?
But this one is giving the same as with on part of one only. It's giving the same show, but so then I copy paste this everything and then change the only Hamiltonian, not everything is same. And that one giving us this weird one.
It's just
New one.
symbol by symbol. The new one.
New?
Yeah.
Yeah.
It is new one. There is should be not percent, should be exponential.
Oh,
Okay, have a good night.
You too.
I think
Thank you.
we are done. So you can any critical questions? Or it seems working now. Last minute questions 1. Last minute questions 2. Last minute questions 3.